So today we are writing exponential equations. So an exponential equation is an equation where the output is multiplied by the same factor every time the input increases by 1. So we're repeatedly multiplying by the same number over and over again, okay? And that multiplier is called the growth factor. Okay, so whatever we're repeatedly multiplying over again, it's the growth factor of our situation. Now, the general equation for an exponential is this. Y equals a times b to the x, where a is the starting amount when we start out at 0, how much are we starting with? And b is that growth factor. So start, and that's our growth factor. Okay, so if you can find those two things in a situation, then we can write an equation for it. All right, so let's see a couple of examples here. We'll start with this one right here, the population of a cell. So notice, on day 0, we have 500 cells. Day 1, we have 1,500. Day 2, we have 4,500. And day 3, we have 13,500 cells. Now, you might be able to look at this and say, oh, I can see what we're multiplying by over and over again. But let's say you didn't. You weren't able to figure out what it is, okay? So in this case, let's do it mathematically by figuring out what would the growth factor be. So what we do is we take the number in the second row, 1,500, and to figure out how much we multiplied 500 to get that, we take that 1,500 and divide it by the first row, and I get 3. So what that tells us is, if we multiply that 500 by 3, we get our 1,500, okay? Now, if this truly is an exponential situation, I should be able to multiply each row by 3 to get the next one. So let's just double check and make sure that that works. So does 1,500 times 3 equal 4,500? It does. So here, times 3. And then does 4,500 times 3 get us 13,500? It does. All right, so this is an exponential situation. All right, and we've just figured out what the growth factor is. So we know that part of the equation. And to figure out what it starts at, just look at day 0 right here. We're starting with 500 cells on day 0. So now we can write our equation. Y equals the starting amount, 500, times the growth factor to the x power, 3 to the x power. So what that tells us is, to figure out the amount of cells on any day, we take 500, which is what we started with, and multiply it by 3 to the power of the number of days, because we're going to repeatedly multiply 3 for that many days. So for example, on day 3, we would multiply 3 times, because we did 3 times 3 times 3, and that's what 3 to the third power means. 3 times, 3 times 3 times 3. Okay? Let's do a slightly harder one, though, this time. Okay? Here we go. The population of a bacteria. Okay, so notice, this time we've got a population bacteria, and it starts at 100,000, and it's actually getting smaller as we go on. Okay? But let's do what we did last time to figure out if there's that consistent growth factor. So we'll start with the second row, that's 75,000, and divide it by 100,000 to figure out what did they multiply it by to get that 75,000. And 0.75, or 3/4. I'll use 0.75, that's fine. All right, so now it's a matter of saying, is it consistent all the way through the table? All right, well, let's find out. Does 75,000 times 0.75 get us 56,250? Look, it does. All right, does 56,250 times 0.75 get us 42,188? 42,180, 87.5. It's close, but if you think about it, we're talking about number of bacteria. You can't have 0.5 of bacteria, so they probably rounded it. So I'm going to go ahead and say, yeah, that follows. All right, so there we go. So notice, we do have our growth factor. It's consistently multiplying by 0.75. We do have the starting amount. Day 0, it's 100,000. So now we can write our equation. y equals the starting amount, 100,000, times the growth factor, which is 0.75 to the x power. All right? So that tells us to find the number of bacteria, we start with 100,000, multiply it by 0.75 to whatever day power it would be. Okay, so hopefully you found this video helpful. If you did, please hit that like button. Also subscribe because it really helps us out. But with that being said, good luck with your math and I'll see you next time.